Well, it looks like I get to start this whole video over. One of my apps interrupted me about a network. All right, this is a deck, and this is what's going on. There's some rot right here. Going back to the material there real fast, and I'm sorry about the focus. This is what was cut out. This is what it looked like on one side. On the back side, this is what was going on. It's just totally deteriorated. And it's the corner of the structure. So yes, even after this is fixed, you still need to resolve why did the corner get so much damage. More than likely, it's this tunnel that was made with this trim. This probably tunneled water down to that point. I'll look for other things like a tree branch that somehow runs water right there. I don't know. I'll look for it. But let's talk about this. I wasn't worried about this falling down when I cut it out because it was already non-supporting, non-contributing. All right, what's going on in the end? This looks like a crush. And so this is the material wants to shear at this point, just shear this board off. The weight of it just wants to go and get rid of it and destroy itself. The top of this is pretty good. It's treated lumber. There's no significant notice of any deterioration. You've got this going into here. This other band board is going into the side of here, or rim joist rather. It's going to the side of this one. This is actually helping this rim joist to some degree. It's also taking up some of the space on top of this supporting, which is 6 centimeters or 2 1/4 inches roughly of supporting on this 3.5 inch post. We'd want it all on there, not just 2 1/4 inches. So it's only this. It was three joists put together to make them to make a header, to make a band board or rim joist. And I say header because that's load bearing at that point. The wall is for the roof. Underside of it, and I'll just talk as I go. We've got somebody putting something here to stop insects from going in, steel wool. And well, I don't see any insects, so that's not a concern. But we have 1, 2, and the third one was there, and this is what it looks like. All 3 of them stacked up. As we slide down, we see they're sitting on top of a 4x4, and you can see your compression going on in there. I'm crushing it to some degree. A lot of this load is crushing it. And then we see, I don't know what the footer, how this foot is working. I see another one over there. It's off center. And then I take note of the joist spacing. They're huge. They're probably 4 foot. The spacing of the joist, and they are 4 foot. 4 foot spacing. So you would need a couple of more joists in there to take care of that, wouldn't you? All right, this is where we don't see everything's okay. On the rest, let me get your location here. That's the corner, and that's the header. Part of the header that we built up to take the load. These are water stains. So what do they do here? Here's the deck, freestanding from the structure, just tied in here to keep the deck from racking, I'm thinking. But as you can see, up here, it's clearly not touching the structure, which is a good thing. And the second post is the deck post. In this case, though, it is load bearing, tying into the structure structurally, the main structure, because they used a spacer of a 1.5 inch board, but then they did something terrible. They put a 1/2 inch foam board between it, so that just kills a lot of the racking ability and integrity. Now coming back to the end post, we can see that pretty much only one, and just a clip, you know, maybe a, what's that, 3/8 of an inch is still, yeah, about a 1/4 inch, 1/2 inch. We'll call it a 1/2 inch. So you've got a 1/2 inch of the one part of the header that was just made up to go there, and a header goes over a doorway, but I'm going to call this a header because you can see it's over this opening down here. Or if you want to refer to it as a floor joist, you sure could. But I'm going to refer to it as a header for us. There's an open, usable space down here. And I'm looking from my perspective, it's the header right now. So, you got this crushing going on. It's pretty dry, and that's not a concern for me. You've got this gap here between it, which stops the moisture from getting into the end grain, which is great. This is non-treated material, which is great to see that, you know, that what happened and what didn't happen. But that did happen. The underside of this deck is all treated, so I don't really care about the deck. I'm more worried about the structure. And here, let me zoom out, or back up rather, and this is the structure. Now it's load bearing because that's the weight of the roof on there. The top part of the roof is on there. And pretty much all that load from here, about halfway down is how you calculate how much is on here. Between this one, halfway down, and this one and the other post, halfway down. Take all the floor space weight, dead load inside. Wall weight, it's two floor heights. It's only a mini attic up there or something. Nothing's up there, but still calculate something into it. And then you got your roof load, along with your possible any continuous dead weight. You know, if there's snow or not, but it's not snow here all the time. So that only gets calculated at 40 pounds per square foot. Here we go. This is just treated lumber. I could care less about it. It's part of the deck. Looks like it was just tunneled and eaten out there. Some animal or something worked on it. And then that's what happened there. So all this stuff you take into consideration when you're checking it out. Now I've got to remember to step in and walk down here. And what do we have? We've got some animals coming out here and doing his duty. And we've got two heights. So it's easy to calculate. This is an 8-foot height. That's an 8-foot height. And the last piece is about 3 feet. So we've got about 19 feet of height on this side of the structure. Coming down, we cut this open just to expose it, to do an inspection on it, see how it was making out. And besides the water, the little slight water on it, no big deal. You don't go tearing that apart. It's sound. So that's good to go. I would have torn the rest of this panel off, but they're expecting company, so I can't do much damage right now. I just got to get this structurally sound again and go from there. So what do? We're going to put back the, we're either going to finish taking this out and put a brand new one in all the way over, or we're just going to put another piece in there. Now it's going to calculate a lot differently, but we're going to put another joist over top of it, band joist treated lumber, so it's now supporting the edge of this, because this is pretty much water's going to come in contact with our material without that spacing, which we do have, which is great. So we're going to put another treated piece of 2x12 material, 2x10. It might go up in size, tying into the joist. So still trying to figure out where this water is coming from. It appears it came from the deck and upwards. The deck and up. We don't see any water trails here. We don't see any water trails here behind this corner trim. Not on the outside edges of it. Nothing. So it's an odd thing. But from there up, there's no hose bib. There's nothing here you can say, you know, a garden hose did it. So there's nothing to look for there. This will then be changed. It's a 4x4 right now, loaded, taking the load of the entire house. So this, it's going to get a new footer. This will get a new 6x6 post. And the new footer won't be so close to that one because, you know, you're going to structurally kill it, right? We can try tying it in, but we've got to pin it and do all this other craziness. We're just going to put the footer over. It's going to have a cantilever of about 1 foot. And this is where the new load-bearing header will go, onto our new post, approximately here. This will stay in place though, still stay in play. But now the load's going to be significantly taken on with the 6x6. And it'll be perfectly cut this measurement so it's not actually taking the load and cantilever. It's going to be in addition to additional support. And then over here we'll do the same thing. But not there. We don't like that anymore. We're going to shorten the load, the span between this one, which has a more significant footer underneath of it. This one's questionable to me. And we're going to come down to the middle of it. So now we're going to put the load here. So now our unsupported spans are going to be very small. It's going to be approximately 5 feet, and then that one's going to be approximately 8 feet. And I'm discounting the one in the middle pretty much all together. I'm just discounting it all together. So that one will be approximately 7 feet. The span to the right, and then the last span will be out here at approximately 11 feet. So 4 foot. It will be a 4 foot unsupported span between this load and this load bearing post. And then this post and that post will be 7 feet. Leaving this in, of course, so it can add to it. Give it some redundancy. Now, why isn't it falling down or tilting or collapsing? Well, remember, this post still is under compression. It's got to crush the post, so it's not going to just crush that post with this wood, with this weight of the structure. It's a lot of weight, but it's not beyond its abilities. And then we have something else going on here. There's plywood behind here, as you see. And this plywood acts like a panel, a shear panel. It's probably plywood around this whole thing based on elevation of the siding. So it all acts like a big giant truss, a shear panel, a truss plate, just giant wood everywhere. So all this helps. All this helps in keeping the building tight and in position. But that's not good. So we'll address that. Now, if this was just that insulation board that a lot of people do, and you just have to put the shear panels on the corner, that is plywood on a corner coming out. Only one panel length per corner pretty much for a structure like this. You might have seen it fall down because it just doesn't have any support after that. After the 4 foot, it's back into that foam board. And you would show it indications like the windows are cracking, they're not square anymore, things like that. But this has no indication of that at all. Finally, let's put the level up there, and you can see it's pretty level. Pretty level, 100% acceptable. So it shows that it didn't fall down. So it's structurally sound. We're just going to go ahead and reinforce it now. Now that's just lumber. What lumber does, it's not perfectly flat lumber. So that's no big deal at all. Now we'll check the plumb on these posts just because we are here. And let's check the plumb real quick, just so I can show you. So that's pretty much in range. It's out by, it's acceptable. It's acceptable. It's still carrying the load. And we have history of the structure being, 20 plus years old, so it's not a crazy thing to get crazy about. Same thing we've got going on here. And our gap is at the end of 4 foot is approximately the same thing. A little more. Maybe it's 3/4 of an inch to an inch out down there. But again, we're going to address this. So it's got a steel anchor down here. I'm going to look at this a little longer since that's an inch. I want to see what's going on. And so I go down here and I look. And I see that they did put a nail into it. I don't see any splitting, which would be indicating that this post is moving left or right. Moving a direction left or right to where I'm standing now. I don't see any rot down here. It's treated lumber. I don't see any cracks in it. It's just a good post. Yes, it's off at a plumb by, I would say, a significant amount. So that would make you think that, well, is the building shifting? Is the building rocking away? Remember all that plywood? So I think not, and I think it's just the guy put the post in, the concrete post in at the wrong location, 1 inch off, and so he created this issue. As we come up here and look at the siding, we grab a 4 foot section of it, and we see it's pretty damn good. It's a crumb. So 100% acceptable. And then we check the other side because we're here. And again, 100% acceptable.